Hi students, good afternoon everybody. I am Waybase SB, Junior College Teacher, Department of Mathematics, RBNB College, Sri Rampur. Today we are going to see the second topic from part 1, that is trigonometry first of class 11th science. Trigonometry first. Up to 10th standard you have studied the trigonometric ratios of acute angle in right angle triangle. If right angle triangle is given, that is A, B, C. Here this is right angle triangle. It is right angle triangle. Then we define the 6 trigonometric ratios of acute angle. If that acute angle is C, then sin C is equal to opposite side divided by hypotenuse. Now here opposite side is AB divided by hypotenuse is AC. So cos of C, it is equal to adjacent side divided by hypotenuse, and it is equal to adjacent side is BC divided by EAC. Tan of tangent ratio, actually tan of means tangent of, tan of C is equal to opposite side divided by adjacent side. And it is equal to opposite side is AB divided by adjacent side of an angle C is BC. Cot of C, it is equal to adjacent side divided by opposite side, and adjacent side is BC and opposite side is AB. Cot of C. Sec of C, it is equal to hypotenuse divided by adjacent side, and hypotenuse is AC divided by adjacent side is BC. Now similarly, cosecant means cosec of C is equal to hypotenuse divided by opposite side, and it is equal to hypotenuse is AC divided by opposite side is AB. So these are the trigonometric ratios of acute angle in right angle triangle that we have studied in 10th standard. Now in 11th standard we are going to extend the definition of trigonometric ratios for any angle. Means if that angle is obtuse angle or any angle, so we can define the trigonometric ratios of that angle. So let's see trigonometric ratios of any angle. Trigonometric ratios of any angle. Trigonometric ratios of any angle. Consider a circle with center at origin and radius R. So we have a circle with center at origin and radius R. So this is the circle with center at origin and radius R. So this point is R comma 0 because this distance is R. Let Px comma y be any point on the circle. So we have taken any point on the circle. Means we can choose that point here, 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 here also. We choose that point in the first quadrant, that is point P, whose coordinates are x comma y. So join the ray OP, this one. Let measure of an angle XOP is equal to theta. Measure of this angle XOP, it is equal to theta. Draw PM perpendicular to x-axis. Draw PM perpendicular to x-axis. In particular, we have to draw PM perpendicular to OX. So this is PM. Now triangle OMP is right angle triangle. So therefore triangle OMP is right angled triangle. Now see. Now OP is radius of the circle and we have radius of the circle is R. So therefore length of OP is equal to R. Length of OP is equal to R. See, point P has coordinates x comma y. So distance of the point P from x-axis is its y coordinate and that distance is P. M means length of PM is y. The distance of the point P from y-axis is its x coordinate, this distance. So this dotted distance and length of OM are same because PM is parallel to y-axis. So length of OM is x. This distance is also x. So there is no need to write it. So PM, length of PM is equal to y and length of OM is equal to x. Now in right angle triangle OMP, theta is acute angle. Angle theta is acute. So we have 6 trigonometric ratios of acute angle in right angle triangle. So what is sine theta? It is equal to opposite side divided by hypotenuse. What is opposite side? Opposite side of the angle theta is PM and hypotenuse is OP. So it is equal to PM divided by OP. But PM divided by OP is equal to, what is PM? Length of PM, that is y, divided by OP. What is OP? OP, that distance is R. So y divided by R. So see, sine theta is equal to Pm divided by OP, and which is equal to y divided by r. Now here, what is y this? What is y? This y is the y coordinate of an angle, y coordinate of point P. Now point P lies on the terminal arm of the angle theta. So which is equal to y coordinate of P divided by distance. See, what is r? R is length of OP, and length of OP is the distance of the point P from origin. So divided by distance of P from origin. So if we want to find out the sine ratio of an angle theta, we must know the y coordinate of the point on the terminal arm of the angle theta and the distance of the point P from the origin. Similarly, we define other trigonometric ratios, that is cos of theta is equal to, we know that the definition for cos of theta or cosine ratio, that is adjacent side divided by hypotenuse. Now adjacent side for an angle theta is OM, so it is equal to OM divided by hypotenuse. Hypotenuse is OP, which is equal to, now OM is equal to x, so it is x divided by r. Again it is equal to, what is x? X coordinate of P, x coordinate of point P divided by distance of point P from origin. So this is cos of theta. Then similarly tan of theta, it is equal to, tan of theta is equal to opposite side divided by hypotenuse. Now opposite side is Pm divided by adjacent side, and adjacent side is OM. So it is equal to y divided by x. And what is this? What is y? Y means y coordinate of the point P which lies on the terminal arm of the angle theta. So it is y coordinate of point P divided by x coordinate of point P. Similarly, cot of theta, it is equal to adjacent side, but what is adjacent side here? Adjacent side is OM divided by opposite side. What is opposite side? PM. So it is equal to OM divided by PM. Now OM is x and PM is y. It is equal to, now this x is the x coordinate of point P. X coordinate of point P divided by y coordinate of point P. And now point P which lies on the terminal arm of the angle theta. Similarly, sec of theta, which is equal to, sec of theta is equal to hypotenuse divided by adjacent side. And hypotenuse, that is OP divided by adjacent side, that is OM, or directly you can write it here, OP divided by OM, and OP is R, OM is X. So which is equal to distance of P from origin divided by X coordinate of P, of point P. Then the last ratio, that is cosec of theta. You know that cosec of theta is equal to hypotenuse divided by opposite side. Hypotenuse is OP, opposite side is PM, OP divided by PM. Now OP is R and PM is Y, R divided upon Y. What is R here? Distance of P from origin divided by Y coordinate of P. So in this way we can define the trigonometric ratios of any angle. So to define the trigonometric ratios of any angle we require two things only. That first, the coordinates of any point on the terminal arm of the given angle and the distance of that point from origin. Once we know these two things, we can define the trigonometric ratios of any angle, of any measure. So these are the definitions of trigonometric ratios of any angle. Now let's see trigonometric ratios and their signs in different quadrants. So see, trigonometric signs of trigonometric functions in different quadrants. Means if your angle lies in first quadrant, let theta lies in first quadrant. Means your 0 is less than or equal to theta is less than or equal to pi by 2. In first quadrant, you know that strictly less than here, because if we take less than or equal to, then that angle lies on, means terminal arm of that angle lies on the x-axis or y-axis. So we have to take the angle which lies in first quadrant. So here should be 0 is less than, theta is less than pi by 2. It means we consider first quadrant. Now in first quadrant, you know that. So as angle theta lies in first quadrant, the point px comma y lies in first quadrant. And you know that in first quadrant x is positive and y is also positive. And just we have seen the 6 trigonometric ratios, which are sin theta is equal to, if this is the circle with center at origin and radius suppose 1 unit, means r is equal to 1 unit here, so sin theta is equal to y, cos theta is equal to x, tan theta is equal to y upon x, cot theta is equal to x upon y, sec theta is equal to x upon 1, that means sec theta is equal to 1 upon x, cosec theta is equal to 1 upon y. So in first quadrant, x is positive, y is positive, so sin theta is equal to y, means sine ratio positive. Cos theta is equal to x, means cosine ratio positive. Tan theta is equal to y divided by x, positive term divided by positive term, positive. Cot theta is equal to x upon y, so positive divided by positive, positive. Sec theta is equal to 1 upon x, positive. Cosec theta is equal to 1 upon y, positive. So in first quadrant, all trigonometric ratios are positive. In first quadrant, all 6 trigonometric ratios are positive. Second quadrant, you know that in second quadrant means your angle theta lies in second quadrant. If we consider a circle with center at origin and radius 1 unit, so this is your point P whose coordinates are x comma y. This is origin O and this angle is now theta. And length of OP here, angle theta lies in second quadrant. So therefore in second quadrant pi by 2 is less than theta is less than pi. Point P lies in second quadrant. So therefore in second quadrant x is negative and y is positive. In second quadrant x is negative and y is positive. So therefore we know that sin theta is equal to y, cos theta is equal to x, tan theta is equal to y by x, cot theta is equal to x upon y, sec theta is equal to 1 upon x, and cosec theta is equal to 1 upon y. So see, in second quadrant sin is negative, tan is negative, cot is negative, and in second quadrant sin is negative, tan is negative, cot is negative, and cosec is negative. Only sine and cosec are positive. In second quadrant sin theta comma cosec theta are positive, and in remaining 4 ratios, remaining 4 means tan theta, cot theta, sec theta, and cos theta are negative. So see, in first quadrant all are positive. In second quadrant only 2 ratios are positive, sine and cosec are positive, remaining ratios are negative. Now let's see third quadrant. In third quadrant your angle theta lies here. So we have to draw a unit circle with center at origin. So this is point P, x comma y, and this length of OP is equal to 1 unit, and this is angle theta. Third one, measure of an angle XOP is equal to theta. Theta lies in third quadrant. You know that in third quadrant your theta is greater than pi and less than. So it is pi is less than theta is less than 3 pi by 2. Pi means 180, 3 pi by 2 means 270. So in third quadrant point P lies in third quadrant. As point P lies in third quadrant, P has coordinates x comma y. So in third quadrant x is negative, y is negative. So x is negative and y is also negative. So we know that sin theta, it is y. So y is negative, so sin is negative. Cos theta is equal to x, x is negative, so cos theta is negative. So now only in third quadrant tan theta and cot theta. So therefore tan theta comma cot theta are positive, and remaining 4 ratios means sin theta, cos theta, sec theta, cosec theta are negative. So remember, in first quadrant all are positive, in second quadrant sin theta and cosec theta are positive, remaining negative. In third quadrant tan theta and cot theta are positive, remaining ratios are negative. Now let's see for fourth quadrant. Now in fourth quadrant, your 0, your theta means 3 pi by 2 is less than theta is less than 2 pi. Means theta lies in fourth quadrant. Means if you draw the figure, your point P x comma y lies in fourth quadrant. This is your angle theta. This point O, or it is O, x-axis, y-axis, negative x-axis, negative y-axis. And you know that in fourth quadrant, P lies in fourth quadrant. म्हणजे point P lies in fourth quadrant. And you know that in fourth quadrant, x is positive and y is negative. X is positive and y is negative. Or if you write sin theta y, cos theta x, tan theta y by x, cot theta x upon y, sec theta 1 upon x, and cosec theta 1 upon y. So see, let's see which trigonometric ratios are positive and which trigonometric ratios are negative. See here, x is positive and y is negative. Y is negative, so sin theta is negative, cos theta is positive, tan theta is negative, cot theta is negative, sec theta is positive, and cosec theta is negative. So only in third quadrant, cos theta and sec theta are positive. Remaining 4 ratios means sin theta, tan theta, cot theta, and cosec theta are negative. So we have seen the signs of trigonometric functions in different quadrants. We have seen in first quadrant all are positive. In second quadrant sin cosec are positive, remaining ratios are negative. In third quadrant tan cot are positive, remaining ratios are negative. And in fourth quadrant cosine ratio and secant ratio are positive, remaining ratios are negative. In short, we can remember the signs of trigonometric functions in different quadrants only by remembering a figure, and this figure is here. So to remember the signs of 6 trigonometric functions, just remember this figure. You know that this is first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. You know that in first quadrant all are positive, so all, for all we have to write the letter A. In second quadrant sine and cosec are positive, just write yes. So yes means sine and its reciprocal is cosec. So you have to remember sine and then cosec. Sine and cosec are positive, remaining negative. Those ratios which are negative, there is no need to write it here. You just remember Sine and cosec are positive, remaining negative. Now in third quadrant, tan and cot are positive. So tan, so write the letter T, tan, and then the reciprocal of tan is cot. So in third quadrant, tangent ratio and cotangent ratio are positive, remaining ratios are negative. In fourth quadrant, cosine ratio and secant ratio means cos and sec are positive. So cos, its first letter is C, so write it here C only. You just remember ASTC. ASTC. All students take coffee. You just remember one sentence that all students take coffee. So all first letter A, student yes, take T, and coffee C. So all students take coffee. So with the help of this sentence, you can write or you can determine the signs of 6 trigonometric functions, 6 trigonometric ratios in different quadrants. So today we stop it here.